Good morning, students. So, today uh, we are going to study one more topic, that is bandwidth, some short derivation about the expression of the bandwidth. So, bandwidth expression. Consider RLC circuit, that is series resistance, inductor, capacitor, RLC, then input voltage V, then here current is I. So the basic equation we know that for current, that is I equal to V divided by Z. This we know, and from previous derivation that to half power frequency we came across some two equations, that is omega L minus 1 divided by omega C is equal to plus or minus R. This we have derived. So just I will segregate the positive and negative parts, that is omega 2L minus 1 divided by omega 2C for the positive R, give the equation number 1, then omega 1L minus 1 divided by omega 1C for negative R. So this has equation number 2. So I will just subtract 1 minus 2 equation, because anyway we need the bandwidth. Bandwidth means the difference between the frequencies. So 1 minus 2 I will make. So it is omega 2L minus 1 divided by omega 2C minus omega 1L plus 1 divided by omega 1C is equal to 2R. So then further for the simplification, I will directly write the equation. That is combining all omega 2 minus omega 1 L. Then here it is plus 1 divided by C, then omega 2 minus omega 1 divided by omega 1 into omega 2 is equal to 2 into R. So in between these steps you try to get this steps. So next further I will take it as omega 2 minus omega 1, that is the difference between. So in bracket L plus 1 divided by C into omega 1 omega 2 equal to 2 into R, because I have taken the omega 2 minus omega 1 as outside. Then equate this equation, that is we have derived omega 2 minus omega 1 is equal to omega naught square, that is 1 divided by LC. This I have taken from previous derivation, that is previous derivation we have taken. Then just substitute the value. What value we will get if I substitute? So omega 2 minus omega 1 into L plus 1 divided by C into LC, okay, equal to 2 into R. So here CC get cancels, then remains only L, that is omega 2 minus omega 1 is equal into 2L is equal to 2R. So again this 2 get cancels, then omega 2 minus omega 1 is equal to R by L remains. So If I further simplify this, this is 2 pi f2 minus 2 pi f1 is equal to r by L. So if I take 2 pi outside, this becomes bandwidth equal to, or you can take it as delta f, it is equal to r divided by 2 pi L. So this is the expression for bandwidth. Okay. Then next, one more concept, we have the selectivity factor. So selectivity factor. So selectivity factor is nothing but ability of the circuit to determine or discriminate or distinguish between desired and undesired frequencies. That is ability to, or ability of circuit to distinguish between desired and undesired frequencies. Okay, so this we also can write it as ratio of resonant frequency to bandwidth. Okay, this also you can write, or this also you can write. So selectivity is equal to resonant frequency divided by bandwidth. Okay, so this is nothing but f0 divided by f2 minus f1. So what is f2 minus f1? Bandwidth is nothing but f2 minus f1. It is nothing but delta f. This is nothing but we have derived r divided by 2 pi L. So therefore if I substitute selectivity is nothing but f0 divided by r divided by 2 pi L. So this is 2 pi f0 L divided by r. So this is nothing but, I will take it as omega naught L divided by r. So this is nothing but quality factor Q naught. So therefore selectivity is nothing but Q factor in series resonant circuit. So for diagrammatically represent like this, if I represent, it will be like this. So for Q factor, so this is the Q value, this is the frequency in terms of hertz. Then for high Q value, here it is high Q value and low R value. Then if the curve is like this, the bandwidth is high, so at this part there is low Q and high R. Okay, so selectivity is also defined as Q naught, that is f0 divided by f2 minus f1, and bandwidth is nothing but f2 minus f1, this is nothing but f0 divided by Q naught. So these two are the equations we need to remember for the solving the problems. Okay, so some problems we'll discuss in the further classes. Thank you.